Welcome back. So here at a very high level is the system development life cycle phases. What I'd like to do is look at each one of these in turn. This will just be an overview. What we're going to do is we're going to take each one of these phases and in different class meetings we'll investigate each of these. The way that you're going to progress in your project is you'll be doing these in turn. Now, in the real world, by doing these in turn, it might lead you to believe that this is some type of lockstep. In other words, I've got to do all of requirements, get that done, and then move on to specifications. It's never that way in the actual production world of IT. You will do something here and jump ahead, and then you'll go back and make a change, and so it will go. So I don't want you to think that in an actual system development life cycle, it's what people might call the waterfall, where I can only do one, and then I move on to the next, and I never go back. This is somewhat fluid. When people are actually doing the system development life cycle, they may be doing something in design and then realize, uh-oh, I forgot this. Then they need to go back, revise their specifications, which may require them to revise the requirements, and then move back and forth, etc. In the interest of time and the fact that this is an academic course, we're just going to do these one after the other. So after you've actually selected a project over the next, not this coming week, but the week after that, after you've selected a project, then you will begin the requirements phase. You're going to do the requirements document. And we're going to talk about the requirements document. You'll know exactly what needs to be incorporated there, and there'll be some guidelines for the document. Now, because there are different types of projects, you know, those things, those 4 different ones that I listed up front, you know, sometimes people apply, and sometimes people manage, and sometimes they document, and sometimes they implement. The documentation may be different depending upon your type of project. And I just don't have time to say, okay, if it's this project, this is what it looks like. If it's this one, this is what it looks like. You're going to have to spend some time thinking about how does my document look and work in the context of my project. Okay? Now, you can ask me, you can ask Professor Hoppe, we'll give you some guidelines, but we're not going to tell you exactly. You know, the other thing I was going to say this later, but I'm going to say this now, and hopefully remember later too. When it comes to your project, if you have questions about the actual implementation, Professor Hoppe or I are not going to answer those questions. If your question deals with a network switch, and you ask me, you know, how is the routing table, I'm not going to answer that question. If it deals with Java programming and you're asking, how do I throw an except, I'm not going to answer that question. So when it comes to actual implementation, you need to work on, it's your project, you need to do it. Now, does that mean you can't use any outside resource? No. Could you use other resources? Yes, absolutely you can. But neither Professor Hoppe or I are going to give you, here is an answer to a specific implementation question. When you have questions about the documentation, we'll answer that. We'll say, yeah, for this specific project, your document is going to be heavy in this section and may not have a lot of that section. Okay? It's going to seem a little difficult because there are so many possible options. It's a big project. A lot of this is new to you. Don't let that hinder you, and certainly don't just stop. Don't do nothing. Okay? If you get stuck, ask. If we say we're not going to answer that, then that's just a clue, okay, I need to find my own resource to help answer the question. The first phase in the system development life cycle is requirements phase. You can't read what Albert's writing on the board. It says, define your problem before the solution. What we said conceptually was the first thing you need to do to solve a problem is to understand the problem. And that's a big part of the requirements phase. The purpose of the requirements phase is to determine the problem. Now, again, the actual verb you use, I don't care. Understand, determine, figure out, analyze. It all means the same thing. You have to understand the problem before we can come up with a solution. In some cases, this will be easy. In other cases, not so much. And you might be thinking right now, well, hey, I had a list of a bunch of projects. Isn't that the problem? Not at all. For example, one of my projects was to investigate the network speed issue. Is there really a speed issue? Is the network really slow, or is that just a perception of the user? Well, how are you going to determine that? You're going to have to investigate. You're going to have to come up with measures, metrics of your own. You're going to have to run some tests and then compare the speed to whatever a benchmark speed is. Bless you. Now, of course, our infrastructure is, 100 megabit per second minimum. We've got some gigabit backbone things. But nobody's going to get that speed, right? If you're transmitting 100 million bits per second, in any network there's a lot of packet overhead there, and there's lots of other things too. What is really the problem? Or let's say that one of the projects was network backup. Why? What does backup mean, and why do you need to do it? Those are preliminary things that you really have to deal with and work with the customer about, okay? The purpose of the requirements phase is to understand what the problem is. Now, how do I prove, how do I document that I understand what the problem is? There's a letter missing in WAT. That should be WHAT, determine what is needed in order to solve the problem. Requirements, you're going to document what is needed. The need is the requirements in order to solve the problem. When you talk to a client, a customer, a user, they're going to tell you lots of things that they want. And one of the difficult aspects of being an IT professional is being able to separate what somebody wants from what actually they need in order to solve the problem. One of the reasons you want to spend time understanding the problem is because sometimes when you expend the effort to truly understand the problem, you may notice that it is not a real problem. It's only a perceived problem. We'll talk more about that when we actually get deep into requirements later on. Okay? So, the purpose or goal of requirements is to figure out what's needed in order to solve the problem. How do I do that? Answer, I need to specify and document the required outputs of the system. When you're doing IT, you start with outputs. If you're going to use IT, you start with inputs. But if you're going to create, in the broad sense in IT, you've got to start with outputs. So you got to figure out, okay, we're coming up with a system here. What outputs does that system need to generate? Why? Because the output is the information. The information is what people use to make a decision and to solve problems. Specify and document the required outputs of the system. One way that we do that, in addition to writing things down, in addition to documenting things, is using a technique called prototyping. A prototype is a non-functional but representation of the product. For example, if we were producing automobiles as opposed to technology, this is a prototype of, it's the next generation Corvette. It's a car. It's the so-called C7 that is going into production soon, be available the end of this year. Believe it or not, before they built a car, they made a model of it. And you're thinking, even with computers and everything else, yeah, this is still done. This is a model made out of clay. Okay? There's some things that the model can tell you that computer simulation really can't. Now, is this a real car? No. There's no doors. There's no inside. It's a big hunk of clay, right? But they've sculpted it to look like the actual car so they can do wind tunnel analysis, right? How does it go through, what's its stability, how will it go through the air, etc. So building a car requires creating a prototype. The same thing happens often in the world of information technology. Let's say that you're going to create an app for somebody, or let's say we're going to put together this web-based inventory project. Okay? Well, what we can do is we can come up with some screens. They don't have to really function. They don't even really have to be on a computer. We could just draw them and say, would this make sense to you? And the user could say, well, what's this button for? And you tell them, say, that doesn't make any sense. Okay? Where's this field? Oh, do you need that? Yeah. The prototype turns out to be a great communication tool between the user, the client, and us as the IT professional. During requirements, then, you're going to be actually doing something in addition to thinking and writing. And that doing is making a prototype. Now, again, some project types, the prototype will be more obvious than others. Okay? So when you get to your exact one, and I'll say more about this in a couple weeks when we revisit requirements. Think of it this way. Everything that we do in the requirements phase is meant to answer this, focused around this statement. Understand the problem. Now, to help us, there are some subphases, or what we call milestones, within the requirements phase. So our process is going to have 5 major phases or steps: requirements, specifications, design, implementation, and maintenance. And within each of those, there will be subphases, sub-steps, and these are oftentimes referred to as milestones. I can't start the project because the user won't give me his requirements. Start making something anyway, otherwise we'll look unhelpful. So our plan is to cleverly hide our competence. You think too much. You can't do something until you know the requirements. You can't build the project until you know what the problem is. Okay? All right. So what are these subphases under number 1, requirements? The first subphase is the problem definition. It's probably obvious what you're going to do here. You're going to explicitly document what the problem is. You're going to write it down. Here's the problem. You're going to say that. If the customer knows what the problem is, and you heard the customer say that, and so you know what the problem is, why should you write it down? Because communication is difficult, and we all make lots of assumptions in communication. Right? When folks are having relationship problems, a technique that a counselor, a human counselor will have, let's say a marriage relationship, is they'll say, all right, I want you two to communicate this way. Person A will say something, and then person B will not respond, not say, but. they'll repeat what they believe the first person said. The reason for that is because when we're in an emotional state, we don't actually hear what the other person says. We interpret a lot of that. So what we're going to do first of all is make sure that we really understand what the problem is by writing it down and giving it back to the user. And that we say, this is what I heard you say, is this really what the problem is? So it's a communication technique. The second subphase under requirements is system requirements. What system requirements does is it's now that I know the problem, I'm going to list exactly what's needed to solve the problem. And again, in the world of IT, I'm going to talk about the outputs of the system. And I'm creating an app, what's on that final screen? If I'm managing a system, what's it going to do? And then the third step, as we mentioned before, the third subphase or milestone is the prototype. The prototype is a good tool for communication. A prototype in IT contains a user interface, it focuses on I/O, but it doesn't actually do any work. Just like the car, you couldn't get inside of it, didn't have an engine, but I can see it, I can visualize it. And the same thing here. We're looking for some way for the user to visualize the ultimate product before it's completed. If the first time the user sees the ultimate product is at the very end, you're probably not doing it right. We've got to show little pieces of it as we move along. Okay. Another way to think about requirements is requirements really exist to help answer the why questions. Why do you need IT support? Why is there a problem? It's really focusing on those why questions that are really foundational to what we do in IT. Okay, I've said that. My plan is to repeat these things a million times to hone in on them, but maybe that's too many times. We didn't include engineers in the product planning sessions because we were art history majors in college. Party! How soon can you build the cloak of invisibility? Let the man think, Clover. Okay. See, the problem is if you, well, let's go on. First phase, requirements phase. Second phase in the system development life cycle is the specification phase. The specification phase is where you're going to determine the features and the specification, here, this is what I want. The specification phase is where you're going to specify and document the required inputs and the functionality of the system. Think of it this way. Imagine we're going to produce some piece of consumer electronics, whether it's some kind of wireless presenter or the next generation smartphone or whatever it might be. You need to think, what is that thing going to do? What are its capabilities and abilities? A wireless presenter, can it move forward and backward? You know, what are the features and functions? In other words, for most technology, we're talking about the user interface. Think about any application package that you work with. Let's pick on a word processor like Microsoft Word. In the menu, in the ribbon, on the tabs, those are all the features and functions of the software. All of that needed to be specified. When you select spell check, it's supposed to check the spelling in your document, etc. Somebody came up with a list of features and functions before the product was actually implemented and said, this is what we need. In order for users to be effective word processors, they need these features and these functions, and here's all the inputs, whether that input is a command or data or what have you. The requirements I mentioned, so the previous step, made the first attempt at identifying the outputs. It's important to notice that the odds of you understanding the problem initially with 100% certainty are 0. As you move through the process, you're going to uncover facts that you didn't realize before. The user's going to say something. So what we need to do in specifications is revisit what we did in requirements. In requirements, we said, hey, this system is supposed to produce this as output. Now that we've thought about some features and functions, there may be additional ones. Okay? The specifications then will completely identify both the outputs and the inputs. If the outputs are the same as the previous step, then fine, no problem. But odds are we might uncover some new ones when we start thinking about the functionality of it. The other aspect of the specification is you will then produce another prototype. Now that you understand the problem better, now that you know what the user wants as far as features and functions, we can produce another prototype that should be better, closer to what the user thinks about. When automobile manufacturers like Chevrolet, trust me, they went through a lot of those prototypes before they got what they wanted just right. It's easier if you build the car out of clay, then you could just smash it down and try again, as opposed to building it out of steel. Right? That's the purpose of a prototype. Okay, so what the subphases under specification phase is we're going to have specifications. This is going to be a document. You're going to write down explicitly what does the solution look like and do. So we have to document what does our product, what's it look like, what's it do. And we're just going to call that specifications. Another aspect of the specification phase is planning. In a real IT system, there'd be a lot going on here in the planning phase. We would do a feasibility study. We'd come up with a timeline here. We'd estimate cost and effort and all those kinds of things. Oh, we're not going to do that in this class. Those are topics that you saw in both CSC 550 and CSC 555 if you took them. Okay? But planning would be an actual part. We're not going to worry about that because the planning is all done. You know the deadline. It's May 3rd. Done. The specification document is important. The specification document is ultimately a legally binding contract. It says, this is what we're going to give the client in exchange for this amount of money. Now in this class, I'm not going to pay you to do it. Okay? But in this class, the specification document is how I'm going to assess your product at the end. Here you're going to tell me, this is what this thing is going to do. At the end, we'll all know, did it do this or not? Okay? So it's not like, you know, I need to guess. It's not like you're graded based upon whether I like you or not or how much you bribed me and things like that. All I have to do is look at this document and say, you said that your product was going to do these things. Does it do those things? You're going to say yes, and then we're going to try it. If it does it, then everybody's happy, right? In the actual world of being a professional information technologist, the specification document is very important. I mean, a client's going to come to you, you're going to investigate it all, and then you can produce that document that says, here's what we can build in exchange for X amount of dollars. It's going to take us this amount of time. No, I don't want to do that. I don't want to do that. Sorry. In our abstract problem-solving model, the specification phase embodies elements of both understanding and planning. Whereas the requirements phase, number 1, focused on why, the specifications phase, number 2, focuses on what. It answers the what questions. What does this product do is the primary question that it's going to answer. Okay? So once we know why we have a problem, why there's a necessity for a solution, then we have to answer what it will do. The specifications phase, therefore, focuses, as we said before, on both outputs and inputs and functions. Now, the one thing that doesn't happen in this phase is the how. I'm not creating algorithms. I'm not doing a spreadsheet. I'm not doing schemas. I'm not doing any of the design work. That's the next phase. But before I can design the system to do something, I have to know what it needs to do. That's specifications. You're watering a plastic plant. Yes, I am. Why? Funny story. Your boss replaced the live plants with plastic ones to save money. My company has the contract to water your office plants. No one ever canceled our contract. Now my career is less important than a gnat's toot in a hurricane. But it's still way better than sitting in a fabric-covered box all day. I need to stop talking to people. Okay, funny story. I agree. Okay. Yeah, let's move on. Number 1, requirements. Number 2, specifications. Number 3, design. The design phase is going to determine how your system functions. Up until now, we've been looking at a product. We've been visualizing a product from the outside in. Now we've got to look at it from the inside out. We have to figure out how is this thing going to do what I said it would do in step 2. How it works, how it solves the problem. As far as the documentation is concerned in the design phase, there are really 2 different things that we're going to focus on. The architecture of the system, which is the big picture, the individual pieces and how they relate to each other, the system architecture. And, oh shoot, where did that go? Oh man, sorry, why am I missing? Okay, let's skip that. Let's skip that. Okay. What you're going to be documenting in the design phase is not only the external architecture, but also the internal organization. And again, I just want to use the terms here. We're going to look at this in much more detail as we move along. But the purpose of the design phase is to really think about how am I going to do this. For example, the specification phase says we need to sort a list of students by their ID number. The design phase says here's how to do that. Here's the algorithm. If you're creating your own sort, you'd list out the algorithm in pseudocode. If you're going to use a system-level procedure call, you specify that along with, you know, the method heading, the inputs and the outputs, and so it goes. So now we're moving from that fairly abstract view of this is what it needs to do to a very concrete view of this is how it's going to carry it out. Yeah, final prototype. We'll talk about that later. Okay. So if the key word with requirements is why, and the key word with specifications is what, the key word for design is how. How will the product solve the problem? This is hard. This is conceptually the hardest phase of IT. If you've done this phase appropriately, the next step, implementation, is easy. You want to think about and weigh all the hard questions of implementation here. How do I add a new user in Active Directory? You can't just say, add a new user. You've got to have the exact procedure. And if you don't know, there are 12 different ways of doing it. So which one is the most effective for this circumstance? And by the way, we don't want anybody to do this manually. We want to create a script to do it and automate it. How do I do that? Solving the problem actually happens here in the design phase. This is the hard part of information technology. Oh, here it is. Darn. So, the aspects, sorry, something got all hunked up here in my slides. When it comes to design, the architectural or high-level design is what are the discrete pieces of the system and how do they communicate with each other. The detailed design is the internals of each of those discrete pieces. When we do design, we have to think both outside in and inside out. And when we talk about design, we'll see a lot more of that. Conceptually, at that abstract level of problem solving, the design phase encompasses issues of both planning and actual creation. Here's where we're actually going to solve the problem. Okay? Have I said that a couple times already? I think so. Yep, good enough. This is a very classic cartoon. It's hard to go to any site that deals with the system development process in IT or CS and not see something like this. I was surveying like a half dozen books, and it was in 5 of the 6 that I looked up. This is a very classic diagram. You could see, if you don't know, it's supposed to be a tree swing type of thing. And this first panel at the top left says how the customer explained it. And it doesn't look very useful. How the project leader understood it, how the analyst designed it, how the programmer wrote it, how the business consultant described it, how the project was documented, what operations installed, how the customer is billed, how it's supported, and what the customer really wanted. The purpose of the little humorous diagram is to point out that there's possible problems at every step because of communication. Even the customer, what the customer really wanted, this tire on a rope, the way it was described was misunderstood, so the requirements were off, and then the specifications were off, and then the design was off, and so it went and so it went. The purpose of an actual process is to always go back to the customer and take documentation and say, is this what I understood you to want? We do that with requirements. We do that with specifications. We do it with the prototypes. We do it throughout, such that when we're all done, the customer isn't surprised and disappointed. Why? Because a good project produces an acceptable product. Acceptable to whom? The customer. If the customer isn't happy, then we haven't done our job. And a lot of not doing the job is traced back to inadequate communication, and that's all related to a lack of documentation. As you're creating documentation for your project, you will likely say, this is a lot of work. Do I really have to do this? And the answer is yes. Why? Because it's how you're going to communicate with your customer. You see, when we say things, it's very easy to misinterpret. If you just listen, you're not going to remember very much of what I say. If you really want to remember something important, you need to write it down. But even writing it down can be fraught with problems. So what you do is once you write it down, then you send it back to the customer and ask them to review that. Is this why there's a problem? Is this what's needed to solve the problem? And so it goes. All right, we're going to try to avoid messing up our tire swing as we go along here. The fourth phase is implementation. Now, if you listen carefully, I said you're actually creating the product in design. And some people would say, well, isn't that what you're doing in implementation? Yes, except this is all based upon the design. When you had the 35 class, Dr. Lippmann told you that the hard part of programming isn't the language. Now that sounds funny because to us, I mean, that learning a language, that is hard. I don't know, I don't know if you did Java or Objective-C or whatever. But the hard part of programming isn't learning a language. That's hard, but that's not the hardest part. The hardest part is the design of the data structures and algorithms. And you do that as a mental process, not at using Java or anything else. See, if you've designed things properly, then the programming, the coding aspect is easy. You just follow your design and you translate that into Java or Objective-C or whatever. That aspect can be straightforward. The hard part is the conceptual design. And you experienced this in the 35 class when you created a program and it didn't work. And you said, why didn't it work? And the answer is because you didn't think about it, right? I mean, Dr. Lippmann's mental toolkit, and I always forget all the different aspects. You know, to solve a problem, how do you do things mentally? Well, you have to remember things. That's similar to a variable. You have to ask questions. You repeat processes, etc. That's all design. Okay? Now, once you have the design set, now you could take that design and instantiate it. Instantiate is just the big IT word that means make it real, make it a system. If you have the design for a network, it's not a real network until you got cables and routers and clients and servers. But you don't just want to take a bunch of cables and routers and clients and servers and throw them all together, right? There needs to be a design that backs that up. So the design is your blueprint for your implementation. In the actual world of information technology, the implementation phase accounts for usually less than 30% of the total effort expended in a project. To do IT right, you expend a lot of effort up front. Unfortunately, many people don't do that. They still only spend 30% in implementation, but they end up spending a whole lot in the next phase, which is maintenance. So, what I'm saying is, if you want the actual creation of your product to go well and right and smoothly, you spend time in those first 3 steps. You think about the design deeply based upon your specifications and your requirements. Okay? There's the big, terrible word, instantiate. Bring it into existence. The design on paper isn't really a website. It's not until you have, all that PHP code on a server somewhere that you really have a website. Instantiate the product. And you know what? There's another big aspect that needs to happen during implementation, and that's testing. Too many IT people want to throw something together and tell, here you go. And they never tried it themselves. Guess what? May not work, right? Test it. Make sure it works. That takes time. And like every other step, we're documenting everything. This will be important. You'll be able to prove that you expended the effort if you have documentation. No documentation? Hard to tell. The final phase is the maintenance phase. Maintenance, think about this, and for those of you that had the 50 course, 550, 850, the analogy that we usually use there is after the sale. You know, if you purchased a car, everything that happens after you bought the car is really maintenance. You need the oil changed, the part breaks, you're in an accident. That's something that happens after the product is actually delivered. So when you're done with implementation, you hand a product over to the customer. Everything that happens after that is part of maintenance. Oh, I needed to expand that a little bit. There are lots of different kinds of maintenance. Don't worry about this, not a very good slide. There's perfective maintenance, adaptive maintenance, et cetera, lots of different kinds, but there are changes to the product after it has been released to the customer. Unfortunately, many IT products expend a lot of effort here. Why? Because the product they handed over to the customer isn't correct. It contains bugs and errors. And because your legally binding contract, your specification phase says, this is going to do this, and when it doesn't, guess what? You get to fix it because you said it's going to do that. Unfortunately, we're not going to have the opportunity to experience the maintenance phase in this class. That's kind of too bad. But to do that, we'd have to have your product complete long before May 3rd, so we could spend some time with it, find the errors, give it back to you, have you corrected, etc. That process just extends the time frame, and I don't want to do that. Okay? We'll talk about it, but we won't be able to actually do it. Okay. You know what? It's a little early, but let's take a break because there's a couple different kinds of things that I want to talk about next. It won't take that long, but I don't think we want to push through this. So let's stop. Let's take a break. Those of you on campus, stand up, walk around, come back in 10 minutes. We'll do it again.